Hey guys, Mr. T here. This is another video. This one is on future value annuities. So future value annuities are a type of investment where you're depositing regular payments into an account, paying compounding interest. You probably have one of these, hopefully. If you have a savings account, that's basically how it's working. You're putting your pay in small little chunks into the account, and hopefully you're generating interest on that. If you're not quite sure, make sure to check with your parents or something to make sure your money's not just sitting there. It's actually growing. Even if it's a tiny percent, it's better than nothing. So, in this situation, because the balance of the account is growing because you're putting more money in there, and it's growing because of the compounding interest on whatever's in the account, it's going to grow to some future value in two different ways, and hence that's why it's called a future value annuity. So some things to think about. Because you're making payments into the account, PMT on the graphics calculator, the TVM solver is going to be negative. The money is going away from you and into the account, it's going to be negative PMT. As the money's growing into a sum that's ultimately going to be yours, the FV, final value, that's the future value, which is the whole goal of a future value annuity, it's going to be positive. It's going to be your money. And then PV can either be 0 or it can be negative, and that depends on the situation. I'm going to do both in this topic. PV is going to be 0 if your account begins with nothing in it, so you start up an account, you don't have any money to start it off with, so you're just going to put money into it regularly starting from nothing. In that case, PV is going to be 0. PV can also be negative, and that's only if the account begins with a sum of money in it. So you're going to encounter two examples here that shows that. And last thing to think about, this is a compounding interest investment. So the interest in a future value annuity is going to you. You're getting paid the interest, and it's paid by the bank on whatever's in the account. So interest, the formula for finding interest is going to be the final amount of whatever you end up with minus how much you actually paid. The difference between those two numbers is how much the bank paid you in interest overall. So let's run a couple of examples here. Example 1, you deposit $600 into an account each year, paying 6% per annum interest, compounding annually. Find the value of the account after 15 years. So, like with all of your compounding interest questions, unless you're asked to do it by hand, you're going to be using the TVM solver. So you press Apps, select one Finance, select one TVM solver, and you're ready to go. So it's asking for the value of the account after 15 years. So when you're answering these kind of questions, when you're using TVM solver, you need to show your input, your calculator input. So you need to write what TVM solver looks like and what you're actually putting in there. PMT, so get into the habit of this, you'll start to remember this list of numbers eventually. PY, CY. Make sure PMT is on end right now. So, what do I know here? Well, from the question information, I'm putting $600 into the account each year. So what are my payments going to be? $600, but it's going to be negative $600 because I'm not getting that money. I'm putting it away. So PMT is going to be negative $600. Future value is what I'm working out, so I'm going to leave that for now. It's compounding annually, so CY is going to be 1, and I'm paying into the account each year, so PY is also going to be 1. PY and CY stay the same unless the question tells you otherwise. PV, so is it starting off with anything in the account? No, we're just making payments into it, so PV is going to be 0. We're solving for FV, so I'm going to put a star there. The interest rate is 6, so we're going to make 6. And the last thing to work out, we can only have one unknown here, so we have to be able to know what N is. N is the number of compounding periods. We're compounding annually, so 1 per year. And if it's compounding once a year for 15 years, the number of compounding periods is going to be 15. So change that. So I've got all of my numbers in my calculator. I just need to highlight FV and press alpha enter to solve, and that tells me it's going to be 13965.58 to 2DP. So your answer to A is going to be, therefore, the account contains $13,965.58 after 15 years. Right, B. B is to find the amount of interest generated. So you need to remember that the interest in this case is paid by the bank to you, and it's calculated on the amount of money that you have been putting in there. So you're going to be putting less money in than you're actually going to end up with. So firstly, we need to know what it grew up to, which you worked out in part A. $13,965.58 is how much you end up with, minus. Now we need to work out how much you paid. You paid 15 times, and you paid $600 15 times over the course of this future value annuity. So on the calculator, 15 times 600. So you ended up with $13,965.58, but you only paid $9,000 into that account. 13,965.58 take 9,000 is going to be $4,965.58. Therefore, account generated $4,965.58 interest for you. So you were paying $600 every year for 15 years into an account paying 6% interest compounding annually. You ended up with $13,965.58, which equates to $4,965.58 in interest that the bank paid you for that. Alright, so that's an example with no starting balance. And I want to show you an example with a starting balance. So as always, it's going to be a TVM solver calculation, so you have to tell me what you put into the calculator. So NIPV, PMT, FV, PY, CY. You decide to put $5,000 into an account, then another $250 monthly, with 8% per annum interest compounding monthly. What's the account balance after 10 years? So what do we know here? We know the interest rate is 8. Decide to put $5,000 in. So you're putting $5,000 into the account. So PV, you're going to have a PV here. It's not going to be 0. You're starting off with money. It's not going to be 5,000 because that indicates you're getting that money. No, you're putting 5,000 away. So it's going to be negative 5,000 in PV. Don't forget to use the little bracketed minus sign at the bottom of your calculator. That's the negative sign. You're paying another $250 monthly. So PMT is also going to be negative $250. It's negative because that money's not going to you. It's going from you into the bank. So negative $250. FV is what we're trying to work out, so I'll leave that alone. Put a star there to show that I'm working that out. I'm paying into the account monthly, and it's compounding monthly, so PY and CY are both going to be 12. So the last thing to work out is what N is. N is always based on what PY is, paying monthly, doing it for 10 years. So 12 months times by 10 years is going to be 120 payments. 120 periods, okay? So put that into the calculator. So I'm ready to solve for FV. So highlight FV, alpha solve. That comes to $5,683.71 to 2 decimal points. So the answer to question A, therefore account is at $56,834.71 after 10 years. Then question B, wiggle that around. Question B, interest. So you have to think a little bit harder about this, because there's a couple of portions to what you paid in there. It is still the total. The bank is giving you money on top of what you're putting in there as interest. So it's going to be what you ended up with, but take away what you paid. But this time what you paid is a bit more complicated. You paid $5,000 to start off with, and 120 instances of $250. So there's a couple of portions to what you're what you actually put into the account here. A lump sum of $5,000 and 120 payments of $250. So 120 times 250. So 5,000 plus 30,000. 56834.71. Take away 30,000 plus 5,000 is 35,000. So you actually paid 35,000 into the account, but it grew to $56,834.71. So the interest is the difference between those. 56,834.71 minus 35,000 is going to be $21,834.71. Therefore, earned $21,834.71 interest over 10 years. So there's your two different examples of how to work a future value annuity question. One starting with one without an initial amount in the account, and then one with. Obviously these aren't the only kinds of questions. You might have to solve for anything else, but the main thing that sets apart what a future value annuity is covered here. It's something that grows because you're putting payments in to a larger amount, and it's only interest on top of that. Any of the other variables you need to find, like time period, interest rate required, the payments required, you just solve for those. That's the beauty of the TPM solver questions, using your calculator to find these investment answers. Hopefully that helps you out, and I will see you in the next video.